So, good morning, class, and welcome to the session. Okay, so let's get started. Okay, so those who have joined online, please confirm if I'm audible.
Yes, sir.
Okay, thanks for confirming. So let's come to this thing. ReLU. What is ReLU? Rectified linear unit and it is a non-linear function. Okay, it is basically it is an activation function, which is it is also non-linear. Okay, and what do you mean by activation function? To differentiate between your significant and insignificant input. Okay? So if input is significant, then what happens to your brain? Your brain cells are activated. Your brain cells are activated. Okay, na? Your brain cells are activated, and if it is a significant input, brain cells are activated, and you do something, or you perform something. तुम कुछ करते हो अगर वो input होता है. अगर if the input is significant, otherwise you ignore it. So the same thing happens in your neural networks also. So if input is significant, then neurons are activated. And output is generated. Otherwise, output is not generated. And I hope you remember the diagram, right? So in this diagram, on this red line, which is on your x-axis, x is less than or equal to 0 and y is equal to 0. So this means no output is generated. But over here, we are taking 0 as a threshold or the boundary, which will differentiate between significant and the insignificant. If the value exceeds 0, then this line is at 45 degree, and that is why y would be equal to x. So basically, if input is significant, then output is equal to input. ठीक है ना, जो output आ रहा है वो input में जा रहा है, हम आगे pass on कर दे रहे हैं. ठीक है, that is the inherent principle of ReLU. ठीक है ना, that is the inherent function of ReLU. Today we will discuss a little more कि ReLU, after coming with the advent of ReLU, how the world of neural networks changed. ठीक है, so before ReLU, आज थोड़ा सा डीप में जा रहे हैं हम लोग. ठीक है, before ReLU, your sigmoid I hope people remember sigmoid. Sigmoid was used as activation function. कई साल पुरानी बात है, ठीक है, before the ReLU came, ठीक है. I think ReLU came somewhere around 10-15 years back. Before that, sigmoid was used as your activation function. But when sigmoid was being used as your activation function, it has its own drawback. उसके कुछ drawback थे. And the major drawback of sigmoid being used as an activation function was your vanishing gradient descent. Vanishing gradient descent. So this is the major drawback if you use sigmoid as a activation function. And that is why in today's world, even if you have an option to use sigmoid as an activation, no one will use sigmoid as an activation function because people know that इसका जो problem आएगा वो vanishing gradient descent आएगा. अच्छा, now read these three words. Vanishing का मतलब क्या होता है? खत्म हो जाना. Gradient is nothing but slope and descent is move down. ठीक है. So remember yesterday we have seen the gradient descent. याद आ रहा है सबको? ठीक है. So the gradient used to vanish. Now, how this problem was coming in your sigmoid? ये चीजें वैसे तो एक फ्रेशर के लिए उतनी जरूरी नहीं है, बट मान लो किसी ऐसे से पाला पड़ गया जिसको डेटा साइंस अच्छे से आता है और उसने तुमसे क्वेश्चन पूछ ही लिया, तो उस दिन के लिए तुम्हें प्रिपेयर कर दो. ठीक है. अब अगर तुम्हें लगता है कोई ऐसा सामना नहीं होने वाला है किसी महारथी से, तो इस टॉपिक को इग्नोर भी कर सकते हो, बट ठीक है, समझते हो. चलो, सो लेट्स ड्रॉ आवर सिग्मॉइड फंक्शन. So yesterday we talked a bit on sigmoid and then probably we talked on softmax also. And I hope people have revised that thing and they have come. Now, ये चीज शायद मैंने पहले भी बताई है, but फिर से एक बार बताता हूँ. So your sigmoid function would be something like this, guys. This would be the boundary of 0.5. And this is obviously your 1. And this line is parallel to your x-axis. This line is parallel to your x-axis. So when a line is parallel to x-axis, y values change or x values change? When line is parallel to x-axis, y values change on that line or x values change? Only x values will change. So it means if you travel on this line, y is constant. Y to constant ho jayega. And what is the slope? Slope is nothing but y2 minus y1. But since y is constant, slope is nothing but y2 minus y1 upon x2 minus x1. But since y is constant, ये तो 0 हो जाएगा, right? And x2 minus x1, this may be any number, this may be any value, but slope तो उस पर 0 ही हो जाएगा, right? Infinite क्यों? ऊपर 0 आ रहा है ना, नीचे 0 आएगा तब infinite होगा. अगर तुम y axis पे travel करोगे तो infinite आएगा, ठीक है? But you are traveling on a line which is parallel to x-axis, so slope would be 0. So keep this thing in mind that if you are traveling on this line or if you are traveling on the x-axis or any other line which is parallel to x-axis, your slope would be 0. Now, this is the sigmoid function. The dotted line is my sigmoid function. अब इस function को जरा 2-3 parts में break कर देते हैं, ठीक है? Suppose करो in this part, ये एक part ले लेते हैं, और let me draw a little bigger part. And this part. Let me say section A, let me say section A, section B, and section C. So do you notice that in section A and C, if not exactly, they are almost parallel to x-axis? Guys, itna yaad aa raha hai? Yesterday we said e power x upon 1 plus e power x. When x was reaching towards infinity, then only this number was reaching towards 1. Yaad aata hai? And when x was approaching towards minus infinity, then this function was approaching towards 0, ठीक है. Or otherwise you can also say ln p by q. The same thing was happening over there also, right? So this value, this section will touch this line somewhere at infinity. कहीं infinity में जाके मिलेगा, right? And same thing will happen over here. So let me take the 0.1, 0.2, 0.3, 0.4, 0.5. So at 0.1, 2, 3, 4, 5, the x values are changing, but the y values are almost same. If not exactly same, they are almost same. So do you notice that beyond a point, your gradient is vanishing? Gradient vanish होता हुआ दिख रहा है. तुम x को कितना भी change करो, slope change होने वाला नहीं है. Why? Because slope is nothing but change in y divided by change in x. X is changing, but the change in y is very insignificant. So this is how your gradient is vanishing. Now let's, if I take this formula e power x upon 1 plus e power x, let me say x is the input and e power x upon 1 plus e power x is your output. So even when the x is changing, output is not changing, or even if it is changing, it is a very small change. So what does it mean? It means beyond a point, even if you keep on changing your x, your y doesn't changes. So that is why it is known as your vanishing gradient descent. Vanishing gradient descent. If vanishing gradient descent occurs, then beyond a point, your model will stop to improve. तुम x को कितना भी change करो, input कितना भी बढ़ाओ, y में कोई change आता हुआ नहीं दिखाई देगा. Vanishing gradient descent will occur. And that was a very big problem with your sigmoid. Beyond a point, model stop to train. You do whatever, model will not improve, or even if it will improve, the rate of improvement would be very insignificant because slope has vanished. But the same problem was overcome with your ReLU function. And you might have noticed I am drawing the ReLU function many times so that you remember ReLU for your lifetime, because this ReLU is very important. In ReLU, what happens? This red plus green line is your ReLU. Am I right? 45 degree. Y is equal to x. Now, till the time x is less than or equal to 0, obviously, yes, y is equal to 0. But if x is greater than 0, then y is equal to x. So since the nature of the formula has changed, you can notice that ReLU will never suffer from your vanishing gradient descent. Vanishing gradient descent se wo suffer nahi karega, because even if your x is high, your y is also high. You change the value, you increase the input, and y will also, or y is nothing but your output. So that is why that is the biggest advantage of ReLU. And trust me, ReLU aane ke baad se these models have improved a lot. सबको वैनिशिंग ग्रेडियंट डिसेंट समझ में आया? ठीक है. जब हमने वैनिशिंग ग्रेडियंट डिसेंट मेरे मुंह से निकल गया है, तो इसका ठीक अपोजिट भी आज इंट्रोड्यूस कर देते हैं. Just opposite of vanishing gradient descent. Oh my God, you are late. You missed something. Just opposite of vanishing gradient descent is your exploding. Explode की स्पेलिंग क्या होती है? ठीक लिखी है ना? ठीक है. Exploding gradient descent. ठीक है. Exploding gradient descent. इस क्लास में कौन ऐसा है जिसको लर्निंग रेट याद है? हाथ उठाओ. याद है? चलो तुम बताओ. हाँ, एक सेकंड. लर्निंग रेट ऐसे बताना है कि जिसको नहीं पता उसको समझ में आ जाए. जब लर्निंग रेट बताना तो लो एलआर एंड हाई एलआर को भी इंट्रोड्यूस करना. अब बताओ. Okay. Hmm. 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 ठीक है, फिर किसी को लगता है और अच्छा एक्सप्लेन कर सकते हैं? बताओ। ठीक है, अगर एब्सेंट है तो छोड़ दो। तुम बताओ, यू वांट टू ट्राई, टेक दिस अपॉर्चुनिटी। हाँ, हम्म, हम्म, इन हाई एलआर, राइट? ओके। हम्म, 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 ओके, ठीक है, fair enough, guys. So, so in vanishing gradient descent, what happens? Your gradient vanishes. Gradient, when gradient vanishes, your model gets trained very slowly. Model gets trained very slowly. It means, in another word, I can say it means errors will reduce. Errors will reduce very slowly. Remember, neural network is an iterative model. So after every iteration, you want to try to reduce the error. But if gradient has vanished, then your model may train, but it will train very slowly. And in another words, I can say your errors will reduce very slowly. That is what your gradient descent, vanishing gradient descent is. In exploding gradient descent, what happens? Your errors start to increase. Your aim was to reduce it, but they start to increase because, and this problem is known as your exploding gradient descent. Now, why does exploding gradient descent happens? This will happen when you have high LR. When learning rate is very high, chances is that you will enter into the exploding gradient descent. That is for sure. ठीक है, तो प्लीज इसको एक पॉइंट को नोट डाउन कर लो. व्हाट इज another disadvantage of high LR? Another disadvantage of high LR is you will enter into exploding gradient descent. And exploding gradient descent means errors, instead of reducing, they will start to increase because you have missed your optimum point. You have missed your optimum point. कुछ ऐसा हो सकता है. And we can recreate the examples. ठीक है, सपोज करो this is your, and you take a very big step. Suppose करो ऐसा है. This was your curve, and after you take your step 1, 2, 3, 4, and you have taken a step number 5, and you went into a territory where model is not able to decide. So the errors may just keep on increasing. If LR is very high, you may enter into your exploding gradient descent. चाहना तो जब हम लोग मॉडल क्रिएट कर रहे होंगे अपने LR को बढ़ा के देख लेना और देखना क्या होता है. Errors will start to increase instead of decreasing. इतना सबको समझ में आया? अच्छा, नाउ vanishing gradient descent and exploding gradient descent. So till this time we talked about ReLU. What is ReLU? ReLU is a activation function. It is a non-linear whatever activation function. But there are some variants of ReLU. जब रेलू यूज करना चालू किया तो पता चला रेलू के भी कुछ प्रॉब्लम्स हैं, तो फिर there were add-ons to ReLU, and the first add-on to ReLU was your leaky ReLU. And remember, this is an add-on to ReLU, so leaky ReLU is also an activation function. वो भी activation function है, slight change है, but है वो ReLU भी, leaky ReLU. अच्छा, leaky का मतलब क्या होता है? लीकेज क्या होता है? कुछ बहते रहना, है ना? तो ये भी थोड़ा सा लीकेज देता है, and that leakage is very much needed for us. So let me again draw ReLU in front of you. So ReLU would be something like this. I hope अब तक लोगों को याद हो गया होगा ReLU कैसा होता है. 45 degree, y is equal to x, and over here x is less than or equal to 0 and y is equal to 3. ठीक ना? This is nothing but ReLU. Now what is leaky ReLU? Y is equal to x. अब तक तो सेम लग रहा है, ठीक है ना? बट देन एक छोटा सा आएगा. Let me do one thing. Let me use the same convention which I have always been using. And this red line is obviously passing through your origin. Okay, so this red plus green line is nothing but your, it is nothing but your leaky ReLU. So in leaky ReLU, do you notice on this red line, x की values क्या होंगी? Can I say it would be less than or equal to 0? But y is negative. Y is negative. Y is not 0. When it is 0, it means no output. But when it is non-zero, it is a generating some output. So basically, in ReLU, what used to happen, that even when x was minus 10 or even when x was minus 100, y was always 0. But in your leaky ReLU, what will happen when your x is less than 0, it will generate a small amount of output. It will generate a small amount of output. And ये जो slope है ना, this slope is the user can decide based upon his requirement. User can decide, and normally default value is 0.01. इसका जो slope है, this is not an angle. This is not an angle. I am telling you about the slope. So अगर line है तो उसका कोई slope भी होगा ना. Normally the slope of this is 0.01. This is the slope of this line. Now, what could be the advantage of leaky ReLU? ये माइंड में क्वेश्चन जरूर आ रहा है, क्यों चाहिए भाई leaky ReLU? नेगेटिव वैल्यूज के लिए when x is negative, why do I want to generate output? उसका आंसर तुम लोग 2 घंटे बाद वैसे समझोगे, लेकिन बट तुमने कभी ऐसा वर्ड सुना है, कोल्ड स्टार्ट एंड वार्म स्टार्ट? वार्म नहीं है, WARM है, वार्म स्टार्ट. क्या होता है? किसी को स्कूटर से कनेक्ट तो नहीं हो रहा है कोल्ड स्टार्टर मॉम नथिंग टू डू विद दैट गाइस ठीक है सी बेसिकली अच्छा इसको कुछ ऐसा समझो सपोज करो लेट्स से एनीवे टुडे आई एम गोइंग टू एक्सप्लेन द नेटवर्क बट थोड़ी देर के लिए इमेजिन करो कि these are your neurons in your brain or in your neural network ठीक है ना so some input is coming let's say input is x1 x2 x3 and then you are sending this input to over here also और मैं काम करता हूँ छोटा सा न्यूरॉन लेता हूँ and let me say input is coming and this input is less than 0 okay so if you are using a ReLU over here then y would be 0 which means no output तो तुम्हारा इंजन कभी स्टार्ट ही नहीं होगा and if engine will not start how would you start to train the model so if you are thinking that at the very starting itself you are about to get a input which is insignificant तो तुम्हारा इंजन स्टार्ट कैसे होगा so in those scenarios what do I do instead of ReLU you use your leaky ReLU so that at least the engine can start so in leaky ReLU even if x is negative y you will generate a small amount of output at least engine will start and the machine will come into the picture and then slowly model will start to train ठीक है anyway जब हम लोग ये न्यूरल नेटवर्क को ड्रॉ करेंगे तब तुम्हें समझ में आएगा कि why do we need a leaky ReLU and what could be the advantage of leaky ReLU ठीक है but remember in leaky ReLU even when x is negative you are generating a small amount of output अच्छा so one was your ReLU another was your leaky ReLU now let's discuss the third variant of ReLU second variant of ReLU that is your soft plus now I am saying soft plus please याद रखना soft plus is your activation function never ever get confuse your soft plus with your soft max tendency रहेगी दोनों को कंफ्यूज करने की जैसे लोग KNN and KMUs कंफ्यूज करते हैं वैसे ही लोग soft plus and soft max कंफ्यूज करने ही वाले हैं ठीक है but soft max was used for your decision making it is used to predict the values soft plus is your activation function okay and it is again a kind of variant of ReLU पहले ReLU आया बाद में soft plus आया obviously so let me again draw ReLU in front of you so that you can do a side by side comparison so this is ReLU and this is the line at 45 degree okay now let me draw the soft plus function in soft plus most of the things remain same x-axis and you have your y-axis so what will happen over here it would be something like this so over here I'll say fx is equal to ln 1 plus e power x what is fx another name of fx is nothing but your y is equal to ln 1 plus e power x 1 plus e power x fx equal to ln 1 plus e power x and we know that so basically what is this this is the equation of this green line this is the equation of this line. ये straight line नहीं है. Can you notice that? It is not a straight line. दिखने में लग रही है लेकिन है नहीं. Can you notice? मैंने थोड़ा सा कर्व देने की कोशिश करी है. Y is equal to ln 1 plus e power x. Now we know that x can take any values from minus infinity to plus infinity. ठीक है. एक काम करते हैं, अपने अपने जो जुपिटर नोटबुक में जाओ सब लोग. आज ओपन है तुम्हारा जुपिटर नोटबुक? ओके ठीक है. तुम भी कॉमेडी टाइप का इंसान हो गया. अच्छी बात है वैसे. अच्छा, so what was my question? ln 1 plus e power x. So np dot log 1 plus np dot exponential, and then I'm saying x. ठीक है. And x equal to, let me say x is equal to 1. So इसकी वैल्यू आ जाती है 1.31. Let me say x is equal to 10. The value is 10.00. Let me say x is 11. Can you notice when x is the, what is this? This is nothing but your y. ये तो y हो गया मेरा. Y is nothing but your output. So do you notice when x is greater than 0, the y is almost, it is not exactly equal to x. But if you keep on increasing the value of x, then do you notice the value of y is slightly more than x. Suppose करो तुमने 10 डाल दिया तो y की वैल्यू देखो 10.00 है. Why? Because you are just, see, इसको कुछ ऐसे याद रखो. अगर मैं यहां से ये चीज हटा दूं, and if I say x equal to 10, तो आउटपुट कितना होगा? 10 ही होने वाला है, बिकॉज पहले तुमने एक्सपोनेंशियल लिया फिर उसका लॉग ले लिया. बराबर? ठीक है ना? सो इवन इफ यू से 100 ऑल्सो और वॉट एवर नंबर, आंसर सेम ही आने वाला, बिकॉज फर्स्ट ऑफ ऑल यू आर टेकिंग एक्सपोनेंशियल. सो एक्सपोनेंशियल इज नथिंग बट एंटी लॉग यू कैन से, और उसके बाद तुमने लॉग ले लिया तो आउटपुट आना है सेम. ओनली थिंग इज ओवर हियर यू आर जस्ट एडिंग 1. So when a number is very large, even if you add 1 or if you subtract 1, the answer will almost remain the same. So even if I say x is equal to 100, now can you notice the output is almost same. ठीक है. But x तो negative भी हो सकता है ना. Let me say -1. So again it is generating some kind of output. Let me say x is equal to -10. So this number, is it a positive number or a negative number? है? अरे पॉजिटिव नंबर है. माइनस होता तो यहां पे माइनस साइन आता. माइनस साइन इज e -05. इट मींस दिस नंबर इज नथिंग बट, ये नंबर जो है इट इज नथिंग बट 0.40 लगा दो यहाँ पे, या 50, ये वाला नंबर है. तो दिस इज ऑब्वियसली अ positive number, but this number is close to 0. So even if I say -100, now the answer is, so you can say x is -100 is equal to -infinity or whatever. So do you notice one thing? Even when x is negative or x is positive, output is always positive. Output हमेशा positive आ रहा है. अब अपने डायग्राम को देखो और जरा देखो क्या उसमें आउटपुट हमेशा पॉजिटिव है. Your graph is in first quadrant and second quadrant, and in first quadrant and second quadrant y is always positive. X can be negative or in second quadrant. X is negative in second quadrant. So basically what is happening, even when x is negative, you generate a small output, and if x is positive, you will generate a output. ठीक है. So basically in leaky ReLU, even when X is negative, you are generating a small amount of output. And then फिर activation functions भी kind of infinite हो सकते हैं. फिर एक activation function होता है tan h. ठीक है, tan h. Tan h सबको पता होगा. Tan h almost looks, so tan h is also kind of your activation function. ठीक है, वैसे ये mathematical function है, sin cos tan. ठीक है, hyperbolic function है, बिल्कुल सही बात. It is a hyperbolic function. Yes, tan h looks similar to sigmoid. देखने में बिल्कुल sigmoid जैसा ही दिखेगा. तो पहले sigmoid ड्रॉ कर देते हैं. sigmoid ऐसा होता है, x axis, y axis, this is a line of 1, you take 0.5 and your sigmoid will look something like this. बराबर, this is sigmoid or S curve. Tan h would be almost similar. y axis, x axis. This line is at +1, this line is at -1, and then the field is same. Over here is in sigmoid, 0.5 was acting as a boundary. In tan h, 0 will act as a boundary. ठीक है, दिखने में सेम आएगा. ठीक है, this would be your tan. Shall we move ahead? Okay. Before we move ahead, let me ask one simple question. So when I say y is equal to beta naught plus beta 1 x1, what is beta 1? Beta 1 क्या होता है? कोएफिशिएंट. और कोई नाम? कोएफिशिएंट होता है, इसको क्या बोलते हैं? स्लोप. बीटा इज नथिंग बट योर स्लोप. स्लोप क्या होता है? y2 minus y1 upon x2 minus x1. ठीक है, जिसने भी इंटरसेप्ट बोला है गलत बोला है. इंटरसेप्ट होता है बीटा नॉट. दिस इज इंटरसेप्ट. This is intercept. बराबर. So basically what does slope tells me? Beta 1 is nothing but slope. So what information does slope gives me? Slopes tells me how much y will change when x will change by 1 unit. बराबर, यही मीनिंग होता है ना. So if x will change by 1 unit, then how much your y will change? That is the real meaning of beta 1, or you can slope. So ये beta naught, what meaning does beta naught conveys? जैसे कि beta 1 convey करता है कि how much y will change when x will change by 1 unit. So beta naught की जरूरत क्या है? What is beta naught? What meaning does beta naught convey? बताओ, तुम सब तो मैथमेटिशियन हो. Intercept has another name. Okay, what meaning does intercept convey? Question. तुम लोग मेरा क्वेश्चन समझ नहीं रहे हो. मैं ये बोल रहा हूँ व्हाट मीनिंग डज बीटा नॉट कन्वेज. तुम लोग मुझे बता रहे हो कि बीटा नॉट का अनदर नेम इज इंटरसेप्ट. वो तो पता है, मैं बीटा नॉट अनदर नेम इज इंटरसेप्ट. बट इंटरसेप्ट का रियल लाइफ मीनिंग क्या होता है? क्यों जरूरत है बीटा नॉट की? इंटरसेप्ट इज नथिंग बट डिस्टेंस फ्रॉम ओरिजिन ओनली. इंटरसेप्ट का मतलब ही यही होता है. सपोज करो ये लाइन है, देन दिस पॉइंट, दिस डिस्टेंस इज नथिंग बट योर बीटा नॉट और इंटरसेप्ट. ठीक है, चलो इसका रियल लाइफ सिग्निफिकेंस क्या है, वही मेरा क्वेश्चन है. क्यों चाहिए? क्या जरूरत पड़ गई क्वेश्चन में बीटा नॉट डालने की? सिर्फ स्लोप से काम नहीं छू सकता था? तुम्हें लग रहा होगा अचानक न्यूरल नेटवर्क से स्ट्रेट लाइन में कहाँ घुस गया है ना. बट ट्रस्ट मी, न्यूरल नेटवर्क में यही क्वेश्चन अभी वापस यूज होने वाला है. यही इसी का एडवांस वर्जन आने वाला है, इसलिए रिवाइज करते हुए चलिए. क्वेश्चन सबको समझ में आया तो आंसर करो. इन दिस सेंस मैंने तुम्हें स्लोप का मीनिंग बताया ना. What is the relation between slope and y? So similarly, the relationship between your beta naught y x, इसका real life meaning क्या होता है? क्यों चाहिए beta naught? If you want, you can take some example. For example, लेके समझाओ. Because अभी मैं beta naught का नाम change करने वाला हूँ, थोड़ा घुमाने वाला हूँ. Okay, ठीक है. If line is passing to origin, then beta naught नहीं होगा. बिल्कुल सही बात है. वो तो मैंने अभी रेलू में तुम लोग को दिखाया. Okay. Yes. Line is not passing through origin, then only beta naught would be there. ठीक है, fair enough. तो इसका significance क्या है? हाँ, but क्यों करना चाह रहे हो increase or decrease? कोई example लेके दो. Beta naught will obviously increase or decrease depending upon whether it is negative or positive. ठीक है, fair enough. Take some example. हाँ. 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 वैसे उसका आंसर सही है. कोई एग्जांपल लेके बता सकते हो क्लास को? हाँ. हम्म. 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 Yes. See, basically, good one. So y is equal to beta naught plus beta 1 x1. ठीक है. So let me say if value of x is 0, then y is nothing but your beta naught. बराबर? Suppose if you don't use beta naught, then your equation would be y is equal to beta 1 x1. It means when x is 0, then y would be 0. But ऐसा जरूरी तो नहीं कि जब x 0 हो तो y हमेशा 0. So to take care of that thing, you are introducing a beta naught. And the example which he has taken is actually a good example. Let me say you book a cab and cab is charging 20 rupees per kilometer. So your equation would be 20 rupees per kilometer. So your equation would be y is equal to 20 into per kilometer, where kilometer is nothing but your x. So ये 20 क्या हो जाएगा? Slope हो जाएगा. ठीक है. But let's say you book a cab and you travel only 1 kilometer. It doesn't mean that you will pay only 20 rupees. Because the base charge itself is, let's say, 50 rupees. तुम आधा किलोमीटर जाओ या 1 मीटर जाओ, you need to pay the base charges. So 50 would be acting as your fixed charge. तुमने एक बार कैब बुक करी तो इतना रुपए तो तुम्हें देना ही देना है. So to take care of those scenarios, for example, let me say age and weight, and take the age and weight of kids. Let me say their age is from 0 to 10 years. Okay, so you are saying that every year the weight will increase by 5 kgs. ठीक है ना? Let me say every year you are saying the weight will increase by 5 kg. So weight is equal to 5 into age. But the day baby is born, उस दिन तो age 0 है, तो क्या उसका weight भी 0 होगा? Weight तो 0 नहीं होगा. Weight कहीं से start होगा. Let me say the weight is starting from 2.5 kg. एक healthy child का weight. Then 2.5 plus 5 into age. तो इसलिए बीटा नॉट चाहिए होता है. Because even when x is 0, there may be some output. ठीक है. ये एग्जांपल एटलीस्ट याद रख लो, है ना? एंड ये कैब वाला एग्जांपल भी याद रखिए। ठीक है, अच्छा चलो, नाउ let's start with the neural network. I think you guys have learned enough so that we can start a neural network. Okay. Now, probably what all concepts which you have learned, softmax, ReLU, whatever, neurons and everything, activation, I'll combine all of them and a network will get created. So yesterday I've shown you a TensorFlow playground. I hope people might have seen that. Yeah. So if you notice that your neural networks normally look something like this. ऐसा कुछ होता है, दिखता है. Now, what are these each cell? Each cell is nothing but your neuron. Another name for neuron is perceptron. So basically, you can consider that each cell or each neuron in this neural network represents the neuron or cell of your brain. जैसे तुम्हारा ब्रेन ट्रेन होता है वैसे ही न्यूरल नेटवर्क भी ट्रेन हो जाएगा. तुम्हारे माइंड, in your brain there are millions of neurons. Obviously over here we'll not have millions of neurons, but if needed you can have it. There is mathematically no stopping point. If your system is very deep, your softwares and hardwares are very powerful. Hardware is very powerful, then obviously you can have it. So each neuron is nothing but a represents your cell of your brain. Okay. Any neural network will have at least 3 layers. And mark my word, I am saying at least. It means it can have more than 3. It will have at least 3 layers. And what would be those 3 layers? At least के केस में क्या होगा? Input, hidden, and output. Input and output would always be there in any neural network. Number of hidden layers can change. So basically you can say that any neural network will have at least 1 hidden layer. Input, hidden, and output. So let me say this is your input. This is your hidden layer. And this is your output layer. Input, hidden, and output. If you have only 1 hidden layer, then that type of network is known as your simple neural network or just NN. वैसे न्यूरल नेटवर्क सिंपल नहीं होता, बट फिर भी वर्ड सिंपल डाल दिया गया, ठीक है। अगर सिर्फ एक हिडन लेयर है, देन इट इज नोन एज योर सिंपल न्यूरल नेट्स. If you have more than one hidden layer, if you have more than one hidden layer, so on the left hand side, obviously you would be having input. Let me say this is your hidden layer 1, H1. Then you add another hidden layer, H2. If you want, you can add third layer. If you want, you can add fourth layer. There is no stopping, and at the end you will have a output. Since you have more than one hidden layer, it becomes your deep neural network. Network kitna deep hai? It means the person is asking how many hidden layers you are using. Because any network will obviously have input and output. So if you have more than one hidden layer, it becomes your deep neural network. यहाँ तक क्लियर है? सब लोग अपने नोट्स प्लीज क्रिएट करते जाना. आई एम गोइंग वेरी स्लो. एंड अभी कोई क्वेश्चन माइंड में आ रहा ना, तो उसको जस्ट होल्ड कर लो. जब मैं बोलूंगा कि हाँ मैंने समझा लिया है, तब अपने क्वेश्चन रखो, ठीक है. अभी माइंड में बहुत सारे क्वेश्चन आएंगे कि मैंने हर बार 3 सर्कल क्यों ड्रॉ किए हैं, बीच में 4 क्यों किए हैं, आखिरी में 2 क्यों किए हैं. वो सारे क्वेश्चन अभी ऑटोमेटिकली आंसर हो. जस्ट होल्ड ऑन टू एनी क्वेश्चन विच यू आर गेटिंग फॉर नेक्स्ट हाफ एन आवर. नेक्स्ट हाफ एन आवर से मैं बोलता रहूंगा और तुम लोग सुनते रहो और अपने नोट्स बनाते रहो. नंबर ऑफ हिडन लेयर्स. Number of hidden layers is a hyperparameter. And I hope people understand hyperparameter. You can control it. It is your choice whether you want to have one hidden layer, 2, 3, 4, 5, 6, 7, 8. कितना चाहिए वो तुम्हारी मर्जी है. Number of hidden layer is a hyperparameter. And remember, we have said that tuning of hyperparameter is a tricky task. So it is very difficult to decide whether I should have just one hidden, 2, 3, 4, or 5. But I will let you know what are the advantages and disadvantages of increasing or decreasing the layers. So based upon that, probably you can make a decision. Number of neurons in each hidden layer, and mark my word, I am saying hidden layer, is also a hyperparameter. So whether you want to use 1 neuron in hidden layer, 2 neuron, 3 neuron, 10 neuron, कितने चाहिए वो एक hyperparameter है. Number of neurons in input layer and output layer is not a hyperparameter. It means user cannot change it, which means number of neurons in input and hidden layer are being calculated. किसी formula से आते हुए दिखाई देंगे. And it is a very simple concept. So it is fixed. Depending upon the data, the number of neurons in your input and output layer are fixed. It is not a hyperparameter. तुम चाहो भी तो change नहीं कर सकते. Change करोगे तो problem में पहुंच जाओगे. Model बेकार हो जाएगा. अच्छा, number of neurons in input layer is equal to number of x variables, and number of x variables तो fixed होंगे in a data, so you just can't change it. So many a times you don't even need to define the number of neurons in your input. Model अपने आप calculate कर लेगा. Number of neurons in your input is equivalent to number of your x variable. Number of neurons in your output is mapped to your number of levels in target variable. Suppose you are building a model on your loan status. The number of neurons in your output would be 2 because your target variable is binary. Suppose you are building a model on your CTG data set. CTG data set में target variable में कितना था? 1, 2, 3 था. So number of neurons would be 3. ठीक है. So number of neurons in your input and output layer are not hyperparameter. In input layer, it is mapped to number of X variable or number of X columns. In output, it is mapped to the levels of your target variable. If your target variable is binary, it will take 2. If it is 3, then it will take 3. 4, it will take 4. यहां तक कोई डाउट, कोई क्वेश्चन प्लीज बताओ. नहीं, ठीक है, fair enough. I am removing it. Okay. So let me say your data has 3 X variables. X1, X2, X3, and then you have a Y. Y takes 2 values, either 0 or 1. So तुम्हारा input तो हो जाएगा ऐसा. This would be your input and तुम्हारा output हो जाएगा ऐसा. 0 and 1. This would be your output. अब बीच में hidden layer तो हमेशा input and output के बीच में ही आएगा. इसीलिए उसका नाम hidden. That's why it's called hidden. Hidden layer is nothing but your brain cells. You cannot see your brain cells. Similarly, you cannot see your neurons, your hidden layers. Now, how many hidden layers? Number of hidden layers is a hyperparameter. बराबर? So I can choose it. तो मैंने बोला भाई 3 hidden layer डाल दो. तो मैंने 3 hidden layers डाल दिए. Number of neurons in hidden layer is also hyperparameter. So suppose I said in my first hidden layer, I want 50 neurons. So 1, 2, 3, 4, 5, 6, and you can imagine this is your 50. Then in your second hidden layer, it is not necessary, it is not compulsory that number of neurons in hidden layer 1 and hidden layer 2 should be same. तुमने hidden layer 1 में 50 डाला, यहाँ पे मन करे तो सिर्फ 5 डालो. Or if you want, you can put 110 or 111, 112. It's not that every time you have to put in multiples of 25 or 50. You can put 49 also, you can put 51 also. जो तुम्हारा मन करे. So number of neurons in your hidden layer 1 and hidden layer 2 can be same also, may not be same. That is your choice. And same thing will follow for your third layer. Number of neurons may be same, may not be same. May be same, may not be same. Okay. Number of neurons in each hidden layer is a hyperparameter. Number of hidden layers are also a hyperparameter. जहां पे मैं hyperparameter बोला ना, अपने माइंड में स्टोर करते चले जाओ, अपने ब्रेन को एक्टिवेट करते जाओ. आखिरी में पूछने वाला हूँ कितने hyperparameters थे, ठीक है? तो तुम्हें ये भी याद हो जाएगा कि what would be the hyperparameters in neural networks. तो अब तक 3 hyperparameter डिस्कस कर लिए. कौन से? Number of hidden layer, number of neurons in hidden layer, or your activation function. Activation function ReLU use करना है, leaky ReLU use करना है, soft plus use करना है. Choice of activation function is also a hyperparameter. 99% of the time we use ReLU only. That is something different. But if you want, you can obviously change it. What could be the another hyperparameter? Learning rate. तुम्हें मॉडल को कितना फास्ट ट्रेन करना है, ठीक है? Learning rate. We will see this when we'll do the coding. We'll combine all those. Okay. So you can control the learning rate also. Now, यहाँ तक सबको clear है? ठीक है. So what I'll do is, I'll remove this thing. And again, I'll keep on drawing. So how does human being learn? Human being learns through multiple iterations. तुमको न्यूरल नेटवर्क भी मैं वैसे ही सिखाने वाला हूँ, बार बार इटरेट करता जाऊंगा और हर एक इटरेशन में एक स्टेप फर्दर ले लूंगा. So till this point, what did we learn? We learn how many neurons in each hidden layer and how many hidden layer. So basically ये दोनों तो हो गया hyper parameter and number of neurons in your input and number of neurons in your output. These are hyperparameter? No, they are not a hyperparameter. Number of neurons in input is mapped to your number of X variables, and this is mapped to number of your levels in your Y variable. Okay. Now let's take one step further. एक छोटा step further लेते हैं. Each neuron, or let me say before that, model is trained from left to right, and obviously from, you can say from input to output. Input से start करेगा और output पे खत्म होएगा. It would, model will train from left to right, or you can say data flows from input to output or from left to right. Forward propagation, yes. It is nothing but your forward propagation. कहाँ से सीखा ये word? Forward propagation, ठीक है, ठीक है. Forward propagation. जब forward propagation मुंह से निकल ही गया है, so data flows from forward propagation, but errors are back propagated. Errors are back propagated. Back propagated means right to left, or you can say from output to input. अभी सिर्फ नोट डाउन कर लो, जब नेटवर्क ड्रॉ करूंगा तो सब चीजें अपने आप समझ में लगेगी. Information is flowing from left to right, errors flow from your right to left. Right to left अगर चीज जा रही, it is known as your back propagation, and this back propagation can again result into vanishing gradient descent. ठीक है ना? Don't write down that sentence. I'll explain how that can occur. ठीक है? यहाँ तक क्लियर है सबका? Forward propagation and back propagation. Before we move further, let's recap हमने अब तक क्या क्या सीखा न्यूरल नेटवर्क में. We saw hidden layer, ठीक है? So basically it is a hyperparameter. How many hidden layer? Then we have seen number of neurons in hyperparameter, ठीक है? Number of neurons in your input and output are not a hyperparameter. ठीक है? They are not a hyperparameter. Information flows from left to right and errors flow from right to left. इसको बोल दिया forward propagation, इसको बोल दिया back propagation. Now एक नया sentence लिख लेते हैं. Each neuron is connected to all the other, each neuron in previous layer. Each neuron in previous layer is connected to all the other neurons in next layer. ये line note down कर लो. Each neuron in previous layer is connected to all the other neurons in the next layer. ठीक है? All the other neurons in the next layer. ठीक है? Now let's do one thing. I'll remove this thing and एक छोटा सा diagram ले लेते हैं. Consider your data has 3 X variables, X1, X2, X3, and you have your Y variable which takes 2 values, either 0 and 1. Number of hidden layers. Let me say number of hidden layers you have given 2. It is a hyperparameter, so I have taken 2 in this example. And number of neurons in each layer. It is again a hyperparameter. Suppose I have given 4. Don't ask me why 4. It can be 4 also, it can be 40 also, it can be 400 also. But let's draw this diagram. कभी कभी मेरा 1 2 जैसा ही दिखता है, ठीक है। Does this diagram matches with this information and this information? इससे मैच करता है? Yes. Now read the last sentence जो मैंने बोला था, नोट डाउन करो. Each neuron is connected to all the other neurons, which means आप सब लोग ध्यान से देखो. So information will come like this. Data flows from left to right, remember? So each neuron, so this neuron will send message to this thing. I hope लोगों को समझ में आ रहा है. And the same thing will happen over here. This will be connected to all of them. मैं और बनाऊं या तुम लोग को समझ में आ गया है? आ गया है? चलो फिर भी बना ही देते हैं, थोड़ा मजा आ रही बनाने में. And obviously the direction is from left to right. Direction is from left to right. And same thing will happen over here. अब देखो, how many I have used very less number of neurons, सिर्फ 4 न्यूरॉन यूज किए, but do you notice कितना complicated network हो गया है, कितने सारे इंफॉर्मेशन आ रहे हैं जा रहे हैं, ठीक है ना. सो अगर परम्यूटेशन कॉम्बिनेशन करो तो फर्स्ट लेयर में 4 4 8 12 एंड देन सिमिलरली 4 4 16, ठीक है. 16 plus 12 is 28 and then you have again around again 8, ठीक है ना. तो 40 combinations हो जा रहा है, ठीक है. So this is how your neural network will look like. Now, any doubt, any question यहाँ तक? सिर्फ यहाँ तक का ही क्वेश्चन है. Okay. Now, let me write each neuron in hidden layer has its own activation function, which means for every neuron in the hidden layer, you would be having a ReLU. Let's say I'm using a ReLU activation function. Then each neuron would be coming with its own ReLU, coming with its own ReLU. So, which means now can people guess that when you are passing the input, some neurons may get activated, some may not get activated. इतना समझ में आ रहा है सबको? ठीक है. मैं क्या करता हूँ, इस डायग्राम को हटा देता हूँ, फिर से एक बार वही सेम डायग्राम बनाने की कोशिश करता हूँ. You have x1, x2, x3, you have y, and this time let me take one more step further and consider your data, and this y is taking 0 and 1, okay, and this data is having 1000 records, okay. Your data is having 1000 records, and now you have said in your input layer there would be 3 neurons, output mein there would be 2 neurons. I am using 2 hidden layers, and each hidden layer is having 4 neurons, okay. But when I'm drawing the diagram, guys, I am taking only one hidden layer, and in that hidden layer I am taking one neuron for our explanation purpose. And whatever happens to this one hidden layer and one neuron, the same thing will happen to all the neurons, ठीक है ना. So let me draw this type of diagram. x1, x2, x3, 0, 1. Okay. Now, so what I have said is, in your hidden layer, each neuron would be coming with its own ReLU function. अभी तक आउटपुट के बारे में कुछ बात नहीं करा. In output layer, we do the prediction. In output layer, we do the prediction using softmax. Remember, softmax can be used for your binary also, and even when data is not binary. Okay. So prediction is done using your softmax function. Now expectation is that people remember what is softmax. Okay. You have your softmax function. Remember कल हमने एक एग्जांपल लिया था ना जिसमें y x की वैल्यू 11, 12, 13 डाला था, है ना? फिर e power a. So your prediction is done using your softmax function. And guys, it is obvious if you are doing the prediction, then based upon your predicted value, you can also find the error. Because error के लिए you need your predicted values and your actual values. Since you are training the model, you are knowing the actual values of your y. And now you are doing the prediction. So I can find the error. And how would I find the error? कौन सा function use करके? मेरे को प्रॉपर वर्ड अभी कल बताया भर के. क्रॉस एंट्रोपी, यस, याद करो. आज से कई साल पहले बताया था क्रॉस एंट्रोपी. क्या फॉर्मूला था? माइनस समेशन ऑफ y log y hat. याद आ रहा है? y log y hat. ठीक है. So if you have, and over here y hat was prediction in probabilities. So predictions are always done in probabilities. Based upon probability, you assign the classes. So at the output layer, I am doing the prediction. Prediction is done using the softmax. And since you are doing the prediction, obviously using your cross entropy, you can find the error. Itna please note down kar lo sab log. Make a note of it. Ab summation of minus y log y hat, ye kal discuss kiya hai humne. I think minus bahar aa raha hai na? Minus bahar aa raha hai. So ignore this thing. Y log y hat. Where y is your actual value and y hat is your prediction in probability. कुछ लोग y hat बोलते हैं, कुछ लोग y cap बोलते हैं. Done? Achha. So I have said that information or the input flows from left to right and errors are from right to left. अब सबको समझ में आ रहा है right to left क्यों? Because errors calculate ही हुए हैं left side में, तो flow भी left side से ही, ठीक है ना? So errors are calculated from your at the output layer. What are the two things I am doing? I am doing the prediction and I am measuring the errors. I am measuring the errors. And I have already said that each neuron is connected to all the other neurons in your next layer. Barabar? And each neuron in the input, in the hidden layer will be having your activation function. Okay. इतना समझ में आया सबको? Now this is the data frame on which you want to train your network. Okay, you want to train your network. So if you want to train your network, what you will do, you will randomly take a record. वैसे you never pass one record, but if you want, you can pass one record. For example, I'm taking one record and then I'll multiply it by a batch. So you randomly take a record and pass to the network. See, you are training the model. It means you know your X values also and you know your Y values also. बराबर? अभी हम prediction नहीं कर रहे. I am training the model. So you know your X also and you know your Y also. Let me say, I am just putting some numbers. Let me say this was 4, this was 7, and this was 11. So you randomly take a record and you pass it through the network. Let me say you have chosen this record. ठीक है? You randomly choose a record. And randomly क्यों choose करना चाहिए? Because we already know the benefits of randomness. ठीक है ना? So what would happen? 4 यहाँ आएगा, 7 यहाँ आएगा, 11 यहाँ आ जाएगा. Is this clear to everyone? यहाँ तक clear है? तुम बताओ. Clear है? यहाँ तक clear है? ठीक है? Now each input is multiplied by a weight, which is nothing but W. अब यहां से थोड़ा मुश्किल होता है territory. By a weight. Normally the weights are a very small positive number. Weights are a small positive numbers, and these weights are randomly assigned. ये 2 लाइन भी प्लीज लिख लो. एंड आई होप तुम लोग एक ऑर्डर में अपने नोट्स बना रहे हो. ठीक है, मैं एक ऑर्डर एक सीक्वेंस में ही बता रहा हूँ तुम लोग को. वेट्स, लोगों के माइंड में क्वेश्चन आ रहा है ये वेट्स कहाँ से आ गए बीच में. ठीक है, क्वेश्चन अच्छा है बट अपने माइंड में रखो, ऑटोमेटिकली वो आंसर हो जाएगा. या मैं क्वेश्चन पूछूंगा फिर तुम लोग आंसर कर देना. ठीक है. Each input is multiplied by a weight. Weights are normally a very small positive number. The default value is normally 0.001. ठीक है. So weights are randomly assigned. So when you would be using a TensorFlow framework, there would be a weight matrix. उस मैट्रिक्स में से वो कुछ नंबर को randomly उठा के assign कर देगा. Why do we find the weightage? Weightage का मतलब क्या होता है guys? भूल जाओ न्यूरल नेटवर्क. What is the meaning of weights or weightage? Yes, correct. So for example, let's say there is a 100 marks paper. 100 marks of paper है, and you are having 4 chapters. Chapters A, B, C, D. And teacher ने बोला chapter A से 50 marks के questions आएंगे. Chapter B से let me say 25 marks के क्वेश्चन आएंगे एंड इससे कितने आएंगे? लेट मी से 20. तो कितना हो गया? 95 हो गया, राइट? और इससे 5 मार्क्स के आएंगे. तो ए का वेटेज कितना होगा? 50/100. बी का वेटेज कितना होगा? 25/100. इसका कितना होगा? 20/100. इसका कितना होगा? 5/100. ठीक है. नाउ यूज द सेम कंसेप्ट. इट मींस द वेटेज ऑफ ए, बी, सी एंड डी कैन बी डिफरेंट. जरूरी तो नहीं ना कि सारे वेरिएबल्स का इंपॉर्टेंस सेम हो. देयर वेटेज और देयर सिग्निफिकेंट कैन बी डिफरेंस. And remember, at this point, you are starting to train the network. You do not know what is the actual weightage of x1, x2, and x3. So you randomly start. Acha, remember, K means I randomly start with something, and then I keep on calculating. So starting में randomly assigned है, बाद में weight would be calculated. ठीक है, इतना समझ में आ रहा है सबको? So let me say you assign W1, W2, and W3. What are W1, W2, W3? They are randomly assigned weightage because not all the variables may be of same significance. Suppose करो you assign 0.001 to W1, you assign 0.00022 over here, and you assign 0.012 to W3. And this 0.001 or 0.002, this 0.012, all these are just the numbers for our example purpose. इतना याद रखो वेटेज क्यों डाला है? बिकॉज जरूरी नहीं कि तीनों वेरिएबल्स एक ही बराबर सिग्निफिकेंट हो सकता है अलग अलग हो. नाउ व्हाट विल all this way. So what is the input over here? Input over here would be 4 into 0.001 plus 7 into 0.002 plus 11 into 0.012. So if you add all this thing, this is the combined input to your hidden layer or combined input to the neuron in the hidden layer. इतना सबको समझ में आया? वेटेज से मल्टीप्लाई कर दिया और अच्छा कभी क्या वेटेज नेगेटिव हो सकता है? वेटेज कभी नेगेटिव नहीं होता, ठीक है? सो इन टर्म्स आइदर इफ यू टेक इन परसेंटेज टर्म्स कैन इट बी मोर देन 100%? क्या किसी का वेटेज 100% ज्यादा हो सकता है? नो, 100% ज्यादा नहीं हो सकता. इफ यू टेक दिस एग्जांपल आल्सो, so weightage of A can be, or for any chapter it can be just 100 only. It cannot be more than 100. In terms of decimal, it can go from 0 to 1. And that is why, if you notice, I have said I am taking a small positive number, which is normally between your 0 to 1. इतना सबको समझ में आया? Weightage. So what is the input to your neuron? Input to your neuron is nothing but, if I draw this diagram, फिर से एक बार ड्रॉ कर लेते हैं. W1 x1, W2 x2, W3 x3. ये नंबर्स याद है कितना था? या मैं इसको 4 7 11, ठीक है ना? 4 7 11. और W1 W2 याद है? W1 कितना था? 0.001, 0.002. ओके, ये 0.012, ठीक है? सो W3 x3 नथिंग बट, हम इसको 11 से मल्टीप्लाई कर देंगे, इसको मल्टीप्लाई कर देंगे 7 से, इसको मल्टीप्लाई कर देंगे 4 से. कोई बता सकता है कि अगर इन तीनों को ऐड करेंगे तो आंसर कितना आ रहा है? किसी ने करा है? 2 मिनट का टाइम लो जरा. आज मैं अपना लैपटॉप चालू कर लिया. गाइस किसी का एचपी का चार्जर है? सबके पास होगा. ये वाला लैपटॉप का चार्जर है, ये वाला लैपटॉप होगा किसी का? अरे होगा, बहुत कॉमन सा मॉडल है. देखो, हाँ लगा. अरे लग गया, हो गया बस, ठीक है, हो गया. ठीक है, अच्छा चलो. स्क्रीन दिख रहा है? नहीं दिख रहा है? नहीं दिख रहा है तो क्या हो गया स्क्रीन? इज देयर अ नेट इशू? नेट इशू तो नहीं दिख रहा वैसे. अच्छा, अभी दिख रहा है? नहीं, अच्छा, देयर इज सम लेटेंसी. I am not able to scroll down. हाँ, कितना है आंसर भाई? यार ये स्क्रॉल ही नहीं हो रहा है. Just give me a minute. So कितना आया? So the input over here would be summation of wi xi, ठीक है ना? Summation means you are summing it up, where value of I would be starting from 1 and it will go till your n. N is nothing but number of neurons in your input layer. Summation of wi xi. Now, what is in this example? What is the summation of wi xi? 0.15. ठीक है ना? चलो. अच्छा, remember just 1 hour back I asked you what is the concept of beta naught intercept. क्यों चाहिए? क्यों चाहिए? ठीक है ना? Remember that concept, beta naught plus beta 1 x1. So now do you notice if you compare this equation y is equal to mx plus c or beta naught, so do you notice you can say this mx is nothing but your kind of your wixi. wixi जैसा दिखता है. And what I will do, I will add one b over here. In data science or in neural network, this b is nothing but your bias. Now you see this equation, summation of wi xi plus b. B is nothing but your bias. And this bias is acting like your intercept. It is acting like your intercept. And normally bias is a large negative number. It is a large negative number. It is a large negative number. It can be 3, -3, -4, whatever. ऐसा एक large negative number होगा. ठीक है. Now, since I am saying bias is a large negative number, it means summation wi, let me write it little down. It means summation wi xi plus b, this combined thing can be positive also and can be negative also, depending upon what is the value of wi xi and what is the value of b. Summation wi xi plus b bias. So it means this entire thing can be positive also and it can be negative also. Now this summation wi xi plus b is passing through your, किससे पास होने वाली है? अरे हिडन लेयर तो ऑलरेडी है, रेलू से पास होने वाली है. रिमेंबर ईच न्यूरॉन कंसिस्ट ऑफ इट्स ओन रेलू. बराबर, हर न्यूरॉन के साथ अपना एक रेलू आ रहा है. Now this combined wi xi plus b is passing through ReLU. So if this wi xi plus b, if this is positive, then output is generated. And if output is generated, then output would go to your output layer. And if output would go to output layer, prediction would be done and error would be calculated. And if this summation wi xi plus b, if this is negative or 0, then output is not generated. अब जरा समझ में आ रहा है लीकी रेलू का एडवांटेज. सपोज करो आउटपुट जनरेट ही नहीं हो रहा है, बार बार तुम्हारा बायस ऐसा आ गया है, यू आर नॉट एबल टू जनरेट आउटपुट, तो इंजन कभी स्टार्ट ही नहीं होगा. तो वहां पे लीकी रेलू काम कर जाएगा फिर, या और यू कैन यूज सॉफ्टवेयर ऑल्सो. ठीक है. So again, let me repeat, summation wi xi plus b is passing through your ReLU, and if this is greater than 0, then information is passed to your output layer. Information is passed to your output layer. At the output layer, you will do your prediction, and you will find the, or you will measure the error, and this error would be back propagated. ठीक है. यहाँ पे ब्रेक ले लो अपना, बिकॉज अभी बैक प्रोपोगेशन कैसे, यूजिंग माई बैक प्रोपोगेशन हाउ वुड आई चेंज द वेट, उसमें dy by dx लगाएंगे. अच्छा, अगेन बिफोर गोइंग टू द ब्रेक, इतना याद रखो, एट द स्टार्टिंग व्हेन यू आर स्टार्टिंग टू ट्रेन द मॉडल, दीज वेट्स आर रैंडमली असाइंड. लेकिन जब स्टार्ट किया तभी रैंडमली था, अब हम कैलकुलेट करने वाले हैं. And how would the calculation be done? Calculation would be done based upon your errors. ठीक है, because weights would be causing some error. Based upon the errors, I will keep on changing my weights. And if you change the weights in the right direction, errors will keep on reducing. And if error is reducing, slowly but surely your model will get trained. ठीक है, यहाँ पे ब्रेक ले लो, कितनी देर का ब्रेक चाहिए? आधा घंटा? अरे चलो आधा घंटा ले लो, नॉर्मली मुझे भी आधा घंटा लग जाता है, तो इट इज 12, टेक ब्रेक टिल 12:35. ठीक है ना, लेट्स मेक इट 12:35. Okay, so let's get started. Guys, can we start? Okay, so we will continue our class till 2 p.m. and so we still have around 70 minutes. 70 minutes में theory तो complete हो ही जाएगी. ठीक है? Theory में ज़्यादा बचा नहीं. Almost done. ठीक है? So again, let me create a diagram. Those who are in online, guys, can they hear me? Am I audible? No answer. Okay, ठीक है. Thanks for confirming. So basically, what the diagram which I was drawing was, you have a data set x1, x2, x3, and you have a y variable. Y takes two values, 0 and 1. So whether it takes 2 or 3 or 5 or 10 doesn't matter. So number of neurons in your input layer is not a hyperparameter. So you have your x1, x2, and x3. Number of neurons in hidden layer and number of hidden layers are hyperparameter. But for explanation purpose, I am just taking one neuron. So input will come something like this. Each neuron in the previous layer is connected to all the other neurons in the next layer. So input over here would be W1, X1. W2, X2, you are multiplying with your weights. And why do we multiply with your weights? Because we don't know how much significant each variable would be. In the neuron, you will do the summation. Wi, Xi, where I is equal to 1 till n. And plus you will add a B. B is nothing but a bias, which is a large negative number. What are weight? W's? W's are your weights. Weights are your small numbers. The small numbers normally between 0 to 1. Now this summation Wi Xi plus B, it passes through your ray loop. It passes through your ray loop. And over here you have your output layer. Output layer में ये 0 होगा, ये 1 होगा. At the output layer, you have your softmax function. Using softmax, you will do your prediction in probabilities. And since you are doing prediction probabilities, you use your cross entropy CE to measure your errors. Okay. If this is greater than, if summation Wi Xi plus B, if it is greater than 0, neuron would be activated. And if neuron is activated, we know that it would be sending the out. Okay. So whatever input, if this summation Wi Xi plus B, if this is greater than 0, then output is equivalent to your input. याद आ रहा है रेलू? So summation Wi Xi plus B यहाँ पे भी जाता हुआ दिखाई देगा. Wi Xi plus B यहाँ पे भी आता हुआ दिखाई देगा. ठीक है. Now you will measure your error. Now remember at the starting, what did I do? These W1, W2, W3 were randomly assigned. Okay. You started to train the model, you have randomly assigned them. But every time I cannot assign them randomly. And remember, as of now, I have passed only one record. Or if you want, you can pass more than one record also. You can pass 10, 20, 32, 64 batches maybe pass kar sakte ho. So when your one record is passing, you are measuring the error. You are measuring the error and error would be back propagated. But what is error? Error is function of what? Error किस चीज का function है? Or in another terms, I can say this error depends on what? Actual and predicted से तो error measure करते हो, but error आ क्यों रहा? What is causing the, on which thing is your error dependent? Your error is a function of what? Error किस चीज का function है बताइए? बताओ गाइस, एरर किस चीज का फंक्शन है? अरे डायग्राम देख के बता दो। यस, एब्सोल्युटली राइट आंसर। एरर इज अ फंक्शन ऑफ वेट्स। एरर इज अ फंक्शन ऑफ वेट्स। सी, जिसको अभी भी समझ बात हजम नहीं हो रही उसको ऐसे समझो। सपोज these weights you are assigning the random weights, but agar weights would have been proper, then probably error would have been 0. If weights would have been proper, then error would have been 0. So basically error is a function of weights. Error is a function of weight. What is dy by dx? Dy by dx is nothing but a slope, and we know what is the meaning of slope. So dy by dx tells me how much y will change when x will change, or x will change by 1 unit. ना समझ में आ रहा सबको? So it means when I say dy by dx, what does it mean? It means y is a function of x. बराबर? Y depends upon x, and that is why I'm saying dy by dx, y is a function of x. Over here, error is a function of weight. Yes or no? Yes. So it means if I do dE by dW, delta error by delta weights, so this will tell me how much error will change when we change the weight. When we change the weights. बराबर? इतना समझ में आ रहा सबको? dE by dW will tell you how much error will change when you change the weights. Now you started with a random weight. So जिनको start किया था उनको हम थोड़ी देर के लिए मान लेते हैं old weight. So what would be the new weight? New weight would be old weight plus change in weight. New weight क्या होगा? Old weight plus change in weight. अगर मैं पता लगा लूं कितना change करना चाहिए तो मेरे को new weight पता चल जाएगा. And change in weight कैसे पता चलेगा? By dE by dW. New weight is equal to old weight plus change in weight. But change in weight का फॉर्मूला कुछ ऐसे आएगा. Old weight plus change in weight. Change in weight is nothing but dE by W into, कोई गेस कर सकता है किस चीज से मल्टीप्लाई कर दे? अरे x कहां से आएगा? वो x क्या होगा? वो x तो होगा, बट वो x का नाम क्या होगा? सोचो सोचो सोचो। हाँ, वो x क्या होगा? अगर मैं लिखूंगा तो तुम लोग सोचेगा अरे यार, LR, लर्निंग रेट। तुम कितना तेज वेट चेंज करना चाह रहे हो? So new weight is equal to old weight plus dE by dW into LR, and obviously you know that LR is a hyperparameter, so you can control it. Normally it is 0.001. TensorFlow में default 0.001 होता है. So new weight is equal to old weight plus dE by dW into LR. So now you get to know the new set of weights. You get to know new sets of weight. नए weights पता चल गए, and this time These new weights are not random, but they are calculated. These weights are not random, but they are calculated. And for finding this d by dw, इसके पीछे में तुम्हारा बैकग्राउंड में gradient descent काम कर रहा होगा, ठीक है ना? Gradient descent and LR काम कर रहा होगा. Now, as of now, how many records had I passed? मैंने पहला रिकॉर्ड ही पास किया था. And this पहला record was also randomly chosen from the 1000 records, correct? Now, you will take the next record. You will take the next record and pass it through your network. And the weights you already know. And you will use the new set of weights. You will use the new set of weights. And the process will repeat. Then you will pass the third record. Then you will pass the fourth record, fifth record, so on. At the end, you will pass your 100th or 1000th record. Total number of record 1000 ही थे जो हमें पास करने थे. When all the 1000 record pass, it is known as your one iteration, or you can say one epoch. पहला epoch हो गया. One iteration or one epoch. Similarly, you can have many iterations. You can have many iterations. हर बार तुम देख रहे हो एरर को वो कैलकुलेट कर रहा है और वेट्स को स्लाइड चेंज करता जा रहा है. And slowly but surely your model will start to take a shape. ये है नेटवर्क. समझ में आया सबको? लगता है तुम लोग सच में चाय पी के आए हो. समझ में आ गया है? अच्छा, अगर मैं कहूँ आके समझाओ, समझा पाएगा कोई? मुश्किल होगा थोड़ा. कोई बात नहीं, मैं एक बार और समझाता हूँ, फिर तुम लोग आओ, ठीक है ना? सो लेट मी गो फॉर माई सेकेंड इटरेशन. ठीक है, सेकेंड इटरेशन में कुछ और चीजें इंट्रोड्यूस कर देंगे. ठीक है, अच्छा. सो ओवर हियर, फॉर better understanding, what did I said? I said that I am taking one record at a time. I am saying one record at a time. But in real life, if you are passing one record at a time, then it will take a very huge amount of time. Suppose karo 10 lakh record hai, and you are passing 10 lakh records, and then it is one epoch. Then you are repeating it once more, twice more. So normally what happens, you never pass one record. You never pass one record, but you pass your record in batches. You pass your record in batches. Now, this batch size can be anything. Normally, we prefer to have a batch size of 32, 64, 128, 256. Normally, we take in power of 2, 256 or 512, whatever. So let me say, if you have 1 million record, do not choose a batch size of 32. Choose a higher order. But if you have only 1000 records, then you can choose a batch size of 32. Even if you don't choose 32, default to 32 here. Default would be 32. We will see that those hyperparameters. So default would be your 32. Okay. And these batches again. So let's say if your batch size is 32, you randomly choose any 32 record out of 1000. And next time when you pass a 32, you do not select the same 32. इस बार bootstrapping नहीं हो रही है. In bootstrapping, you make a samples with replacement. This is without replacement. जो 32 पहले पास हो गए, next time वो 32 पास नहीं होने वाले. ठीक है? So make a note that batch size is again a hyperparameter. Batch size is again a hyperparameter. And it is not mandatory that you choose 32, 64. You can choose 33 also, 34 also, 50 also, 100 also. But experience बोलता है कि जब तुम 2 के पावर में लेते हो तो normally अच्छे results आते हैं. So that this is just a advice, and it is not a mandate. So choosing a power of 2, it is just a advice, not a mandate. You can choose 50, 60, 100, whatever, 75, कुछ भी choose कर सकते हो. So batch size is also a hyperparameter. Default value in TensorFlow is 32. So even if you don't give batch size, वो 32 पकड़ के चलने वाला है. ठीक है. अच्छा, now basically I'll keep on repeating this thing number of times. Suppose, and why only suppose? It is obviously possible. Suppose your data is very complex. Example, emotion recognition. Suppose whether the person is smiling, or let me say not smiling, whether the person is sad or happy. As a human being, ये काम कितना मुश्किल है? चेहरा देख के बता सकते हो? अब किसी ने चेहरा छुपा रखा हो तो बात अलग है कि इमोशंस पे कंट्रोल कर लिया हो, अंदर ही अंदर दुखी हो बेचारा. But let me say, if you see a face, probably you can make it out whether the person is sad or happy. Not always, but let's say कुछ के चेहरे वो हमेशा उदास रहते हैं, वो छोड़ दो. कुछ हमेशा हंसते रहते हैं, वो छोड़ दो. But probably this task is, I will say, it's very easy for human. But this task is very tough for machine. Because चेहरा सेम है, आंखें, दो कान, दो नाक, whatever. सिर्फ कहाँ पे डिफरेंस है? So if you see a laughing face, or let me say if you see a sad face and a happy face, क्या डिफरेंस है दोनों में? Can you facial muscles? हाँ, but क्या मैथमेटिकली क्या डिफरेंस है? कितना चेंज हो जाता है एंगल? एंगल तो चेंज होता है, बट कितना चेंज होता है क्या बता सकते हो? बहुत मुश्किल है. बट you can decide that because तुम बचपन से देखते आ रहे लोगों को, and your model has slowly got trained, right? But जब मशीन ट्रेन करना स्टार्ट करेगी, उसके बाद कोई हिस्टोरिकल बैकग्राउंड तो है नहीं, वो तो अभी चालू कर रही है. So for you it is a tough, it is a easy task, but for a machine it is a quite a difficult task. ठीक है. So suppose your data is very complex. So now what does your mind says? Your mind says, let me add more hidden layer. कल का एग्जांपल याद आ रहा है? टेंसरफ्लो प्लेग्राउंड. अगर डेटा कॉम्प्लेक्स था तो ज्यादा हिडन लेयर्स बढ़ा रहा था मैं. So you will say, let me add more hidden layers. Okay. Your mind will say, let me add more hidden layers. And let me add more neurons in each hidden layer. Let me add more neurons in each hidden layer. और कुछ करना चाहोगे? Can I say, let me increase the number of iterations? अगर डेटा सिंपल तो 5 इटरेशन में सीख जाता, मुश्किल है तो शायद 10 लगे, 50 लगे, 100 लगे. और कुछ करना चाहोगे? Let me increase the LR by small amount. बहुत ज्यादा तो नहीं, लेकिन थोड़ा सा बढ़ा के देखते हैं, शायद जल्दी ट्रेन हो जाए. और कुछ? So इनको नोट डाउन कर लो. If your data is very complex, probably you may wish to make these kind of changes. ठीक है ना? And all these are quite obvious. You would try to increase the number of hidden layers. You would try to increase the number of neurons in each hidden layer. Obviously, number of iterations, and probably try to increase the LR by small amount. And do you notice I am saying by small amount because you already know if you increase it by a very large amount, तो क्या हो सकता है? Optimum point मिस हो सकता है and exploding gradient descent भी हो सकता है. ठीक है ना? अब जैसे जैसे सिखाता जा रहा हूं अपना आंसर भी चेंज करो ना। ये आंसर कल तक ठीक था, बट आज उसमें एक और लाइन जोड़ दोगे, दैट हाई एलआर कैन लीड टू एक्सप्लोडिंग gradient descent also because you have missed your optimum point. ठीक है ना? With every iteration keep learning. ठीक है? Now तुम्हारा ब्रेन कहता तो है कि मोर हिडन लेयर लगा दो, बट सोचो अगर मोर हिडन लेयर लगाओगे तो कुछ और भी हो सकता है क्या? इफ यू एड मोर हिडन लेयर, मोर न्यूरॉन्स इन ईच हिडन लेयर, तो क्या होने वाला है? प्रॉब्लम साइड में सोचो क्या प्रॉब्लम ला सकता है। एडवांटेजेस तो ला रहा है, इट कैन सॉल्व अ कॉम्प्लेक्स डेटा, इट कैन हेल्प यू सॉल्विंग अ कॉम्प्लेक्स प्रॉब्लम, बट हर चीज की कुछ फायदे नुकसान है। टाइम कं बट टाइम कंज्यूमिंग क्यों होगा? सो बेसिकली योर मॉडल विल बिकम वेरी कॉम्प्लेक्स, बहुत ही डीप नेटवर्क क्रिएट हो जाएगा। सो इट विल आस्क फॉर मोर कंप्यूटेशनल पावर, इट विल आस्क फॉर मोर कंप्यूटेशनल पावर। जो काम अभी 16 जीबी में हो रहा था, अब काम वो शायद 32 जीबी पे ही होगा। अदरवाइज वो बोल सकता है sufficient memory not found or whatever. And obviously if you are building on a on your cloud, you will not get a memory issue because cloud can just expand. So it will become more complex, computation power needed is more, and obviously time will also increase. चलो मान लिया तुम बहुत पैसे वाले हो, पैसे की कोई समस्या नहीं है, ठीक है, बड़ी कंपनी ने ये छोटा मोटा पैसा किया है, जहाँ $1000 लग रहे थे 2000 दे दिए, ठीक, काम खत्म। बट मॉडल तो अच्छा आना चाहिए। अब मॉडल अच्छा आएगा कि नहीं उस एंगल से सोचना चालू करो। अभी तक जो सोचा वो टाइम एंड मनी के हिसाब से सोचा। एंड रिमेंबर दिस ड्रॉबैक, इफ यू आर मेकिंग अ नेटवर्क वेरी डीप, टाइम एंड मनी कंज्यूम विल ऑब्वियसली increase. Okay, but let's say I do a sacrifice, I do a compromise, I do a trade-off with time and money. अगर बेटर मॉडल गारंटी कर दो तो ठीक है भाई, पैसे का नुकसान झेल लिया थोड़ा, पर क्या मॉडल हमेशा बेटर होगा? ऐसा तो नहीं खराब हो जाएगा, हो सकता है क्योंकि मैंने बोला है इसलिए। कैसे खराब हो सकता है? क्या प्रॉब्लम हो सकता है? हायर लर्निंग रेट नहीं, लर्निंग रेट तो हमने बहुत थोड़ा सा बढ़ाया है। इफ यू वांट यू कैन रिड्यूस द लर्निंग रेट। कभी कभी हम लोग लर्निंग रेट रिड्यूस भी कर देते हैं। ठीक है, बहुत सही बात है। इट कैन ओवरफिट, दिस इज वन ऑफ द इशू विच यू कैन नोटिस, इट कैन ओवरफिट, इट कैन ओवरफिट, ये लाइन नोट डाउन कर लो, अच्छा पॉइंट। इट कैन ओवरफिट इफ अ नेटवर्क इज वेरी डीप। Okay, so model can overfit, but then you have some techniques to find out the overfitting, and probably since you can find out where the model is getting overfitted, you can take care of it also. But ठीक है, overfitting is also a good point. और कुछ भी हो सकता है क्या? So basically, if you are adding many hidden layers, theoretically, if you keep on adding the layer, your model performance will keep on improving. That is theoretically. But in practical, if you are adding many hidden layers, your model would start encountering a problem of vanishing gradient descent. तो vanishing gradient descent एक तो sigmoid function use करोगे तो वहां से आ सकता है. So that is why I am not using it. I am using ReLU. But if you add many hidden layers, then again you are likely to enter into a problem of vanishing gradient descent. ठीक है, तो ये प्रॉब्लम याद रखना कि ऐसा हो सकता है, and based upon that you decide कितने hidden layer लगाएं. ठीक है, now let's try to understand that why adding the more hidden layers will make your model into vanishing gradient descent. अच्छा, जब vanishing gradient descent होता है तो क्या होता है? Why are we calling it to be an issue or a problem? उसको प्रॉब्लम क्यों बोलते हैं हम लोग? वही एक जन बोलो प्लीज. Okay. Model stops to train or model trains very slowly. ठीक है. Guys, those who are in online, am I audible?
Yes,
online?
sir.
Okay, ठीक है. Thanks, guys. Okay. For this example, what I'll do is I'll take a very simple thing. Let me say this is your input. In my input, I'm just taking one neuron. Then you have your hidden layer 1, hidden layer 2, hidden layer 3, hidden layer 4, and then let me say you have your output. In output, you are having your 0 and 1. And just for our example, I am taking one neuron. But whether you take 1 neuron or 20 neuron or whatever, the problem would still be the same thing would be happening. So let me say this is X1. So this would be X1 W1. Okay. And weights can be same or weights can be different also. So this would be your, over here, let me say my X1 W1 likhte hi nahi. Over here, let me say the weight is W1. Over here, the weight is W2. Then the weight is W3, and then the weight is W4. Okay. And then you are passing. You are passing. Okay. This is the output layer, and some कुछ लोग ऐसा भी बोलते हैं कि यहाँ पे W5, W6 भी कर सकते हैं. If you want, you can add W5, W6. So at the output layer, you will do your prediction, and using your cross entropy, you will measure the error. You will measure the error. See, again I am saying these W1, W2, W3, W4 can be same, can be different also, because remember now I am starting to train the model. Model को train करना start कर रहा हूँ. So these are randomly assigned, and when it is randomly assigned, they can be same also, but they can be different also. ठीक है, इतना याद रखना. When model is about to train, बाद में तो क्या calculate होगा. So now error is function of what? Error किस चीज का function है? Error is a function of weight. तुम लोग अपने ब्रेन को इटरेट नहीं कर रहे हो, हर इटरेशन के साथ कुछ तो नया ऐड करो. एरर इज अ फंक्शन ऑफ वेट, ये आंसर ठीक है, दिस इज द करेक्ट आंसर, बट इट इज नॉट द बेस्ट आंसर. गिव मी द बेस्ट आंसर. इन दिस एग्जांपल एरर इज अ फंक्शन ऑफ व्हाट? और लेट मी चेंज द क्वेश्चन. एरर इज अ डायरेक्ट फंक्शन ऑफ व्हाट? अब देखो, मैंने एक वर्ड डायरेक्ट ऐड कर दिया, अब तो आंसर चेंज करो. ना, एरर इज अ डायरेक्ट फंक्शन ऑफ व्हाट? Error is a function of weight, agreed. But in this example, error is a direct function of what? अब मुद्दा ये है कि तुम इसको गूगल पे भी ढूंढोगे तो मिलेगा, कैसे ढूंढें गूगल पे, है ना. ये डायरेक्ट फंक्शन किस चीज का है? सपोज करो थोड़ी देर के लिए तुम लोग का ध्यान वहां पे सही जगह जाए, थोड़ी देर के लिए मैं चलो हटा दे. अब बताओ, ये डायरेक्ट फंक्शन किस चीज का है? विच क्लास? नहीं, 01 तो पहले भी था, है? अच्छा चलो, तुम लोग को एक और हिंट देता हूँ, और इस बार ऐसा हिंट है जो तुम लोग ने अपने मैथ्स में काफी सुना होगा. कभी तुमने ऐसा देखा है, dy by dx is equal to dy by dp into dp by dq into dq by dn into dn by dx. ये कट जाता था, ये कट जाता, ये कट जाता, और आखिरी में dy by dx is nothing but dy by dx. ऐसा इक्वेशन देखा है ना? अब जरा यही सेम चीज सोचो, think on the same basis with this example. क्वेश्चन क्या है? एरर इज अ फंक्शन ऑफ वेट, बट एरर इज अ डायरेक्ट फंक्शन ऑफ लास्ट. एरर इज अ डायरेक्ट फंक्शन ऑफ W4. एंड अगर किसी को समझने में प्रॉब्लम आ रहा है तो उसको ऐसे समझो, had W4 been very proper, then your error would have been 0. अगर W4 सबसे सही होता, आइडियल होता, then your error would have been 0. But W4 is direct function of W3. W3 is direct function of W2, and W2 is direct function of W1. इतना समझ में आ रहा है सबको? और अब जरा सोचो, ऐसी इक्वेशन इसलिए तो बनाई, आ रही बात समझ में? Now error is a direct function of W4, and W4 is a function of W3. W3 is a function of W2. W2 is a function of W1. So basically अगर हम इसको कुछ ऐसा लिखें, so it can be dy by dW4 is equal to dW4 by dW3 into dW3 by dW2 into dW2 by dW1. तो ये कट जाएगा, ये कट जाएगा, और सपोज करो यहाँ पे तुम्हारा ये आ जाएगा dy dW आ जाएगा, ठीक है ना? तो वैसे ही कुछ, ठीक है. Now see, now what will happen? इसको हटा देते हैं ताकि थोड़ी जगह आ जाए हमारी। ये सेम चीज है ना, सी देखो W4 error would be direct function of W4 and W4 is a direct function of W3 and W3 is a direct function of W2 and W2 is a direct function of your W1। तो वही ऐसा ही रिप्रेजेंटेशन तो लिखा है, ठीक है। नाउ व्हाट विल हैपन, अब प्रॉब्लम क्या आने वाला है, दैट यू ट्रेन योर नेटवर्क in forward propagation, but errors are propagated in back propagation. Errors are back propagated. Errors are back propagated. It means the first change would be coming at W4. And after you have changed W4, then only you will change W3. And once you have changed W3, based upon how much you have changed W3, that would be used to change your W2. And same thing would be in your W1. Now, what is new weight? Or let me say new W4 would be DE by DW4 into LR plus W4. और इसको ऐसे लिख देते हैं, let me say W4 plus DE by DW4 into LR, बराबर? Yes or no? Because error is a direct function of W4. Now, I have been saying that weights are normally less than 1. Weights कैसे होते हैं? Less than 1 होते हैं, ठीक है। And learning rate is normally your 0.001. So DE by DW, this thing is also less than 1. Slope तो बहुत slight होता है ना, it is less than 1. DE by DW is less than 1. Learning rate is less than 1. If you multiply two numbers which are less than 1, then resultant would be even lesser than 1. Suppose करो तुमने 0.1 and 0.1 multiply कर दिया तो आंसर क्या आ जाएगा? 0.01. So if you multiply two numbers which are less than 1, the output would be even lesser than 1. So if I say, and will people agree that this number is a very small number? ये एक small number होता हुआ दिखता है, बराबर? ठीक है। Now what is this? जो मैंने encircle करा है वो क्या है? जो blue में encircle करा है वो क्या है? अरे error नहीं, this is the change in weight ना, this is change in weight, बराबर? New weight is equal to old weight plus change in weight, तो ये तो change in weight है ना। So can I say the change in weight is less than 1 or it is a very small change? So fair enough. So new W4 is equal to W4 plus change in weight, which is less than 1. Less than 1. Let me say ये 0.0024 था. Let me say I am just putting a number. Now, so the new weight has changed only by 0.0024 because new weight is equal to old weight plus change in weight. Change in weight यहाँ पे कितना हो गया? 0.0024. This is just a number. Now what you will do? You will use this thing and you will try to change W3. And in again W3 में तुम क्या रखोगे? You will say NW3 is equal to OW3 plus तुम DW3 by DW4 कुछ करोगे तुम, ठीक है? Change in 3 with respect to 4, but change in the new weights itself, the NW4 itself was very small. Or can I say the change at W4 was small? So change at W3 is going to be even smaller because again you will multiply with LR and LR is normally less than 1, it would be 0.001. So the if change at W4 was small, change at W3 would also be small, and change at W2 would also be smaller. It would even be smaller, and change at W1 would even be smaller. So do you notice that changes are vanishing? Vanish होता हुआ दिख रहा है. जो चेंज W4 पे हुआ उससे कम चेंज W3 पे, उससे कम चेंज W2 पे, उससे कम चेंज W1 पे हुआ. ठीक है, fair enough. So by the time you come to W1, new W1 is equal to old W1 plus delta W1. Delta W1 means change in weight. Let me say this change in weight is almost 0. Because तुमने 4 बार 0.001 से मल्टीप्लाई कर दिया. So if this is close to 0, then new W1 is equal to old W1. If not exactly, but then almost का साइन ड्रॉ कर देता हूं. बराबर. So at the starting, these W1, W2, W3 were randomly assigned. But after you have passed your first record, or after you have passed your first batch, now you have changed the weights. After passing the first batch, you have changed the weights. But do you notice the weights at the W1 are still same? Because NW1 is same as OW1. Because the change in weight was very small. Now, imagine one thing. This W1 is same. W1 is not changing, let me say. So whether you pass the first record or you pass the second record or third record or the 1000 record, this model will not further change. जब W1 ही change नहीं हो रहा तो यहाँ का W2 भी तो change नहीं होएगा. In next iteration, when you are passing the second record, because the input at this point, let me say this is cell number A, cell number B, cell number C. Since W1 is same, you don't need to change W2 also, because जो input यहाँ पे था, this input is still remaining the same. So why do you want to change W2? Why do you want to change W3 or W4? So basically, why vanishing gradient descent will happen? Because errors are back, and the first layer is most important, but the change at the first layer itself is almost 0. Suppose करो तुम्हारा input same आ रहा है बार बार, तो output change होने ही वाला है. If W1 is same, आगे की सारी चीजें so if your model is very deep, you can enter into a vanishing gradient descent. ठीक है, सबको समझ में आता है? एक बार मैं वापस एक्सप्लेन करूंगा. देखो गाइस, फिर से देखो यहाँ पे. So let me say this is input. This is your hidden layer 1, hidden layer 2, hidden layer 3, and hidden layer 4, and this is your output. Okay. Now, over here you are having W1, W2, W3, W4. Okay. Now, error is a direct function of W4. Okay. So what would be the new weights? New W4. So error is back propagated. Will people agree the first change would be coming at W4? because error is a direct function of W4. So new W4 would be old W4 plus change in W4. What is change in W4? LR into DE by dW4. LR is less than 1 and DE by dW4 is also less than 1. Slope is less than 1. So this resultant number is even lesser than 1. Even lesser than 1. Okay. Now, so basically, then this same concept would be repeated between your W3 and W4, because W4 is a function of, error was the function of W4, but W4 is a function of W3. So the change in W4 or change in W3, new W3 would be equal to old W3 plus change in W3. But change in W3 will depend upon how much you have changed your W4. But change in W4 itself is less than 1. So change in NW3 or this change would be even lesser than W4. And same thing, the change at W2 would be lesser than W3. So change in W3 हमारा क्या हो जाएगा? अगर हम इसको फंक्शन में लिखना चाहें तो change in W3 would be 4. W4 is a function of W3, dW4 upon dW3 into LR. LR would be less than 1 and W4 by W3 would also be less than 1. So ये चीजें और reduce होती चली जाएंगी. So things will keep on reducing, and by the time you come to W1, your new W1 would be equivalent to old W1 plus change in W1. But change in W1 is almost 0, which means new weights or new weights at layer 1 and the old weights are same. और जब weights ही change नहीं हो रहे तो आगे का मॉडल भी change होना बंद हो जाएगा, because your model is forward propagated. इतना याद रखो, जब इनपुट सेम है तो आउटपुट भी सेम रहेगा. And input will change only when your weights are changing. जब weight change ही नहीं हो रहा है तो मॉडल खत्म. So remember one thing. So basically 4 layer, 5 layer is not a very deep model. You may not encounter a problem of vanishing gradient descent. But अगर तुमने 10 layer लगा दिए तो ये प्रॉब्लम आने ही वाला है. 8 लेयर 10 लेयर लगाए तो समझ लो अब वैनिशिंग ग्रेडियंट डिसेंट आने वाला है. ठीक है, इतना क्लियर है सबका? एंड अगर यहाँ तक क्लियर है तो प्रॉब्ली थ्योरी ऑफ न्यूरल नेटवर्क इज कमिंग टू. एक लास्ट चीज डिस्कस करते हम चलते हैं, और वो लास्ट चीज है ड्रॉप आउट. So if you remember yesterday's lecture, I said to overcome the overfitting, I would be using 2 ways. One way was your cross validation. Another method was your dropout. Okay. So what does dropout mean? So again, dropout is a hyperparameter. जिसको भी note down कर लो. It is a hyperparameter. Whether you want to use it or you don't want to use it, that is your choice. That is your choice. ठीक है. And the size of dropout. Size of dropout is also a hyperparameter. कितने लोगों को drop करना है? That is also a hyperparameter. But what is dropout? Dropout, if someone says dropout is equal to 0.2 or 0.3 or 0.4 or 0.15 or 0.25, 0.2, 0.3, 0.4, all these are your hyperparameters. So size of dropout is also hyperparameter. But let's say if someone has given 0.2, which means 20%. So it means after every iteration, you randomly, and mark my word, randomly remove, or you can say drop 20% of the neurons. हर इटरेशन के बाद 20% न्यूरॉन्स को हटा दो. नाउ विल यू एग्री कि ये हेल्प करेगा ओवरफिटिंग से ले? देखो कैसा. फर्स्ट ऑफ ऑल लेट मी एक्सप्लेन. सपोज लेट मी से दिस इज माय hidden layer. Sorry, this is my input layer. This is my hidden layer. And consider this has 200 neurons. You have second hidden layer. Again, you have 200 neurons. And then I have a output layer. So तुम्हारा मॉडल कुछ ऐसा होगा, बराबर? ऐसा होगा. And same thing would be here also. And same thing would be here also. So if how many neurons do I have? Count the number of neurons in your hidden layer. Can I say number of neurons in hidden layer are 200 plus 200? 400 neurons hai? And I have given a dropout of, let me say 0.2. So 400 ka 0.2 kitna hoga? 80 hoga. 400 into 0.2 is nothing but your 80. So out of these 400 neurons, you randomly remove. So let me say during your first iteration, you had your all 400 neurons. In second iteration, you remove 80 neurons and you are having just 320 neurons. In third iteration, again, you are having 320 neurons. But these 320 may not be same. They may not be same. They might be an overlap. They might not be an overlap. Because हर बार तुम 80 neurons को randomly हटा दोगे. ठीक है? अच्छा, now do you notice in what is overfitting? In overfitting, your model mimics the data. Model mimics the data. But if you are randomly removing the neurons, the model cannot mimic the data. हर बार तो तुमने उस चैनल को ब्रेक कर दिया ना. If you are breaking the channel, it cannot mimic the data. You are breaking that network, and if you are breaking that network, model cannot mimic the data. So this is also a very good technique to control your overfitting. So normally try to take 0.2 or 0.3 और बहुत हुआ तो 0.4, 0.9 वगैरह मत ले लेना, है ना. मॉडल वरना कुछ आगे नहीं बढ़ेगा. 20%, 30% बहुत हो गया. ठीक है. So you randomly remove some percentage of neurons. अगर इसको कुछ ऐसा समझो, अगर मैं चाहूं इस क्लास में किसी दो लोगों की बहुत अच्छी दोस्ती ना हो, तो मैं कभी किसी को यहाँ बिठा दूं, कभी किसी को वहां बिठा दूं, रैंडमली रिमूव करता रहूं, तो वो हार्ड कोडिंग नहीं होगी. यू विल नेवर मिमिक द डेटा. ठीक है ना. एक जनरल पैटर्न आ जाएगा, बट इट विल नॉट मिमिक द डेटा. यहाँ तक क्लियर है सबको? ठीक है. सो आई थिंक वी विल स्टॉप ओवर देयर. एंड कल क्लास है. कल क्लास है. एक काम करो, कल की क्लास कैंसिल करा लो. कैंसिल करा लो मींस आई एम नॉट कमिंग एंड आई एम नॉट टेकिंग लेक्चर फॉर टुमारो. सो आई विल आस्क उत्कर्षा टू असाइन सम असेसमेंट और व्हाटएवर. ठीक है. बिकॉज़ कल मेरे को ऑफिस में थोड़ा काम है. आई जस्ट कांट कम. ठीक है. बट तुम लोग क्या करो, तुम लोग ये सारी थ्योरी रिवाइज करके आओ. ऑब्वियसली ऑन फ्राइडे वी विल मीट, बट उससे पहले तुम लोग करो एक काम. क्या काम करोगे बताओ. क्या काम करोगे? कुछ नहीं बोल रहा। अच्छा चलो कोई बात नहीं। एक मिनट अभी क्लास से जाना नहीं, एक चीज इंस्टॉल करके ला रही थी तुमको। आर यू एबल टू सी द जुपिटर नोटबुक? देखता है?
Yes, sir.
तो तुम लोग को करना क्या है, अभी कुछ कोडिंग मत करो तुम लोग। ठीक है, सो import TensorFlow as TF. So TensorFlow is a framework offered by the Google. ठीक है, so when I import the TensorFlow I don't get any error, but तुम लोग को error आएगा because तुम लोग के में install नहीं होगा. So then what you do, you set TF dot underscore version and underscore. So मेरा जो TensorFlow का version है वो 2.8.0 है. ठीक है, so what, and then similarly you also import Keras. ठीक है, so basically Keras is also a framework. I'll not say it's a framework. TensorFlow is a framework. Keras is a wrapper on a TensorFlow. So when you install your TensorFlow, check the version. The version should not be less than 2.5. मेरे में 2.8 आ गया है, but it should not be less than 2.5. Install any version above 2.5. Normally, if you are doing installation, it would automatically install a latest version. If you want, you can don't install the latest version because latest version कभी-कभी beta version आ जाते हैं जिनमें error होता है. So you can install just one previous version or whatever. ठीक है, import your install this TensorFlow. TensorFlow कैसे install करोगे? pip install TensorFlow करो on your Anaconda prompt. After installation, come back and run this command. Check the version and then import your Keras. Import Keras लिखा, run किया, अगर error नहीं आया तो ठीक है ना. देखिए Keras का वर्जन कौन सा आया. Keras हाँ, Keras का वर्जन भी मेरे में 2.8 आ रहा है. ठीक है, सो आई थिंक 2.5 वर्जन भी चल जाएगा तुम लोग के में. ठीक है, सो ट्राई इंस्टॉलिंग योर TensorFlow and try installing your Keras. Sorry, Keras को मैं इंस्टॉल नहीं करना. If the TensorFlow installation goes proper, Keras would be automatically downloaded. But सब लोग प्लीज इंस्टॉल करके लाओ. कोई ये मत सोचना क्लास में करेंगे, ये थोड़ा टाइम लेगा. ठीक है, इट मे टेक 5-10 minutes डिपेंडिंग हाउ फास्ट योर नेट इज. और कुछ ऐसे लोग भी हो सकते हैं जिनके में ये इंस्टॉल नहीं होगा. मान लो किसी का लैपटॉप बहुत पुराना है, जावा अपडेटेड नहीं है, सी अपडेटेड नहीं है, तो उनके में हो सकता है इशू आए. तो जो इश्यूज आएगा उसको गूगल सर्च आउट करना और उसके पैचेस डालना. ठीक है, बट फॉर मंडेज, सॉरी नॉट फॉर मंडेज क्लास बट फॉर Friday's class is this installation is a mandatory part, because on Friday when we will meet, probably just half an hour of revision, no more new theory as of now, half an hour revision and then we move towards the coding. ठीक है, 3-4 दिन तुम लोग ने बहुत मस्ती करी, सुनते बैठे हो, ठीक है, अब टाइम आ गया थोड़ा कोडिंग करो, ठीक है guys, so with this I'll end the session. Thank you for